It takes an incredible amount of money to build a universe from scratch. Right now, a purely virtual space simulator called Star Citizen has burned through over $500 million in development. When we move from the digital world to the physical one, the scale gets even heavier. Companies are deploying massive automated machines designed to chew through solid bedrock, carving out subterranean transit networks at a rate of a mile a week. Above ground, state-backed conglomerates are laying down high-speed rail networks that span entire continents, backed by revenues exceeding $160 billion. We live in an era overflowing with venture capital and engineering breakthroughs. It is easy to look at these massive budgets and assume that with enough cash and clever design, we can simply buy our way past any obstacle. But as these mega projects scale up, whether they are digging under cities, orbiting the Earth, or rendering digital galaxies, they hit a ceiling. They trigger an exponential pushback from the laws of physics, geopolitics, and economics. Let's call it the friction of scale. Take orbital telecommunications. To supply the globe with high-speed internet from space, satellite companies need to push massive amounts of data back and forth to Earth. This compares Q-band and K-band frequencies. K-band's tighter wavelengths achieve high data rates with much smaller receiver dishes. But these tight waves carry a physical penalty. They are so small they get absorbed by falling rain. The signal is blocked by weather, known as rain fade. Down on Earth, the Boring Company ran into a different kind of physical limit. Beneath the Las Vegas Convention Center, they attempted to outpace traditional tunneling methods by shrinking their bores down to 12 feet in diameter to dig faster. But geology pushes back. Rushing through high water tables and soft soils meant dealing with heavy, pressurized wet earth and toxic chemical accelerants. Rushing the operation in these tight, hazardous environments led to severe chemical burns for workers and thousands of dollars in safety violations. You cannot bribe the weather, and you cannot intimidate bedrock. Optimizing for extreme bandwidth or record-breaking speed inherently breeds critical vulnerabilities in the final system. The friction does not stop with the physical world. Consider the China Railway Construction Corporation, or CRCC. They are one of the most capable engineering firms on the planet, responsible for structures like the 80,000-seat Lusail Stadium in Qatar. Their logistical footprint is staggering, spanning from Middle Eastern transit systems all the way to massive 1,000-mile rail lines piercing deep into Angola and Senegal. But international infrastructure requires international cooperation. Because of CRCC's scale and its deep historical ties to the Chinese military, they hit a geopolitical wall. U.S. sanctions and international blacklists sharply curtailed American investment and restricted their global integration. And you do not even need to be laying physical steel to hit these kinds of national boundaries. The exact same geopolitical walls exist for invisible assets like server data. This animation illustrates data sovereignty. Nations are erecting massive bureaucratic firewalls, mandating that data generated by their citizens must be stored and processed locally. To legally move information across a border, companies must navigate rigorous security assessments and secure certified legal translations. Whether it is an embargo stopping a freight train or a compliance law halting a digital packet, human borders act as an absolute, unyielding limit on globalized ambition. So what happens if we remove the physical weather and the geopolitical borders entirely? Even in purely virtual worlds, we run into the friction of capital. Modern video games require staggering investments to build sprawling digital cities and hire Hollywood-level talent. Titles like Cyberpunk 2077 have topped $440 million in development and marketing costs to deliver massive, celebrity-driven experiences. This chart shows the harsh reality of that financial gamble. A survival game called Undawn cost over $140 million to make. In early 2024, it generated roughly $287,000 in monthly revenue. Games like this prove that you can pour hundreds of millions into development and still face mass layoffs and zero market traction. Injecting limitless capital into a project does not force reality to cooperate. Economic friction remains absolute, even in worlds built entirely out of pixels.
From shrinking satellite waves in orbit to 12-foot tunnels under the desert, to data laws and digital entertainment budgets, the pattern holds. The defining mark of a successful modern megaproject is never the size of its initial budget or the excitement generated by its press release. True engineering success is defined by how meticulously a system navigates friction. It is about anticipating rain fade, complying with international data laws, and balancing ballooning digital budgets before the money runs out. We possess the technology and the capital to build the future, but the universe will always charge a toll.